Okay, so we're going to begin here by talking about the vertical forces first and then talking about the horizontal forces on both A and B. So with A, we have the Earth pulling down on A. So the force of Earth on A is pulling down, and we have the normal force here of B on A. All right, and then on B, we have essentially the normal force of A on B pushing down. So A is sitting on top of B, pushing down on B, and we have the force of the Earth here on B, which means the ground itself is going to push up. That'll be the normal force of the ground on B. Now, what we're going to do is we're going to talk about what happens in between these two surfaces, because we know initially the bottom surface here we don't have to worry about. We're going to assume here that there's no friction for the first two, A and B. So we don't have to worry about any friction in B, but when A is on top of B and B wants to slide to the left, A is going to have a frictional value on B. Now, depending on how hard you pull it, the two boxes will slide or they won't slide. So here we have to imagine trying to pull harder and harder until they are just about to slide. Now, if they're just about to slide across each other, all right, if A is exerting a force to the right on B, all right, B wants to move to the left, A will exert a force to the right. Now, when we're talking about between their surfaces, we're only concerned about the relative motion between their surfaces. So if B wants to slide to the left, A wants to, but does not slide to the right, which means the force of B on A will be exerted in the opposite direction. So you'll have a frictional value of B on A going to the left. Going to the left. So, and the rest of the forces for B, you'll have a larger force F that pulls both A and B together. However, it's just exerted on B, so that's why it only shows up in B's force diagram. So first, we're going to handle A, because they're asking for the maximum value of the acceleration and then ultimately finding the force on the object. So we know the coefficient of static friction because they don't slip and slide across each other, they stay stationary, is 0.35. So looking at Newton's second law horizontally and vertically for A, we are going to have the frictional force of B on A pointing to the left divided by the mass is equal to the acceleration. And we're going to have the normal force of B on A minus the force of the Earth. So in this case, this would be MA times G is equal to 0. So the normal force here of B on A is 20 newtons. If I substitute in the coefficient of friction times the normal force divided by the 2 kilograms, we can determine that the maximum acceleration of A is going to be 3.5 meters per second squared. Basically, this tells us that anything more any force larger that allows both objects to accelerate greater than 3.5 meters per second squared, B and A surfaces will slip and they will be accelerating at various rates then. So now looking over at B, the assumption we can make about the acceleration is 3.5 meters per second squared. That would keep the two blocks together moving as one. So horizontally we have F, that force that we're looking for, minus the friction of A on B, divided by the mass of B, which is 6 kilograms, is equal to the acceleration, which is 3.5 meters per second squared. So because we are looking at the surfaces of A and B, all right, and that they're not sliding across each other, this will be essentially the same calculation here for the force of friction of A on B, because we'd be using the normal force of A on B as the normal force that is relevant to this problem. The normal force of the ground on B is between the ground and B. However, when we're looking at this friction, it occurs between A and B. So this here would have a normal force of 20 newtons. And because the boxes are not sliding, this is going to be the coefficient of static friction times the normal force of B on A. So we are going to have F minus 0.35 times 20 newtons divided by 6 kilograms is equal to 3.5 meters per second squared. So when we substitute in and solve, we get F minus 7 is equal to 21, and F would equal 28 newtons. And that would be the maximum force exerted for F to allow the two objects to accelerate together. Now, once it reaches a speed, okay, essentially F will go away. Then you have the two blocks moving together as one. If you have nothing pulling it to the right, A and B will not want to slide together. Sorry, A and B will not have a static friction force between the two of them. Therefore, the two force diagrams will just be the vertical forces only